You guys want to see this, or you just want to keep going with what we're doing? This is like a little bit more involved. It's kind of more involved. I say we keep going with what we're doing.
It's up to you, man.
Yeah. So anyhow, that's where I started to go off on maps, because I was passing a map around, and I started to have the question of, how do I need to be passing this? Do I need to be, returning a map and reassigning? Or do I need to do an address? Or is it just automatically changing it as I pass it around? And so that's how I went down that road. So we left off somewhere over here in this code. Who could tell me where it was? We did the do-it-yourself server, file server, setting cookies, getting cookies. Where did we leave off?
I remember serve mugs, I think.
Did you guys see the Redis clone? We saw the Redis clone. Is that right? And Rot 13, I said that's interesting. I think we ran it, but we didn't look at it. Is that right? Y'all remember Redis? And then we did do it here. This is how we'll find out. Yeah, so I was just looking at the video there, see where we were at. And we're on 25. And I did start recording again. Perfect. So here we go. Default serve mux. So the first thing was on 24. We kind of saw how to build things up from TCP all on our own. And, right, basic TCP server is all this stuff here, accept, copy, create a connection. And then we're listening, and then we loop over and we accept anything that comes in, and then we copy that. Whatever comes in, we copy it back out to the response. And that's the telnet server. And TCP server, sorry. And then we did like a Redis clone. So the main function is listening, right? And it gives us a listener and an error, and then a listener and a close. And then we're doing a loop here, and anything that comes in, we accept it, assign that to a variable, which I've called con, and then pass that to a function called handle. And then handle up here, we have the scanner, right, is scanning over that connection, so it'll get all the lines. And now let's loop over all the lines. And for each line, let's get the text, and then break it up into fields, right? And then for the fields, we'll be able to switch on the first word. So the first word that kind of came through could be part of, get, set, and delete. And that's how we did the Redis thing. So a little bit of a review there. And then, basic HTTP server, do it yourself, right? We have net listen, and it gives us our listener, which we called server here. And then accept any, we're looping eternally, just listening for things to come in. Anything comes in, we accept it. And assign that to a variable, which I've called con for connection. And then pass it to handle connection. We put go here to mean it can handle many connections concurrently, many requests concurrently. And then up here, handle con, pass in the connection. And we do a new scanner over that connection. And then scan, right, gives us each line. And then this is the text of each line right here. So we print it out. So when we see that one run, that'll print whatever we enter. That'll just print the headers, right? The request line headers, because that's all that came back from. Like if we go to a browser and we connect to 9000 when this is running, right? Then it sends over our request, and the request has headers, and that's all we're getting. And so that's what the server does, is print it. And then here, same thing down below, right? All the TCP stuff. And then up above, we got the method out. So from the headers, we're able to pull out the method, because the very first line in a request is the request line. And that's this image right here, which I keep on my desktop, the request line, right? This is such a pain. I need to find that image. Browser, server, the headers, request line. The first line is the request line. So I got 22 minutes to be amazing. I'm going to show you something amazing in 22 minutes, okay? And so, you know, we were able to get access to that, and then here we have like even more, right? Same stuff down below, TCP, listener, connection, handle the connection. And then up here, you know, same thing, we're getting the method out, but we're also now writing a response. And so we're writing, we have our request line, which is the first line, and then we have our headers, that's in the request, going from the client to the server. I really need to find that image. Is that image still here? It's not going to be there. Is that it? No, but that looks great. Is it here? Those are my videos I need to upload. Final. It's not there. Is it in my downloads? I don't know what I did with it. Anyhow. So anyhow, we get the client makes a request. When the request goes over, there's the request line and then the headers. The server responds, and the response is the status line, and then the headers, and then the body. You could also have the body in the request if it's a form, if it's a post. And so here we're creating the status line right there. So IO write string, there's the status line, which is HTTP 1, 200, okay. That's what you need for the status line. And then we're giving it the content length, so this is a header. And then we're writing back the carriage return in the new line, and then sending back the body, which is hello world 2, which is just going to print out as text in the browser. So that's kind of cool. And then we did all that. We brought it all the way up to this one here, where we're writing back an even bigger response in our body, and kind of a whole page, right? So it's kind of like a do-it-yourself HTTP server. And then we said, okay, to heck with doing all that. This is easier. We could just use listen and serve. And if you look at listen and serve, I bet you will find some of the stuff that we were doing in the background, right? Like listen and serve, return server, listen and serve, like server, like what's that? And that's a server. I don't know where you find it, but I've dug around in here before, and you start seeing some of the same stuff like TCP, accept, and I'm not totally sure where it is, but I'll try to find it. Listen and serve. And then function listen and serve returns an error. Server is that. It's a server. Return server, listen and serve. Here we go. Server, listen and serve. So this is another listen and serve. So just to follow that again, I came here and I clicked on listen and serve. And then when I got here, here's func listen and serve, and it returns a server listen and serve, right? Just looking and see what that is. And this one here is different than this one. I'm not totally sure why. Because here I'm at server.go. Where did I go here? I'm still at server.go. So how's that different? Listen and serve right there. Oh, you know, this is, so listen and serve, right? Here's a server. And a server's a struct. And then this is, when we have a pointer to a server, just looking for a pointer to a server, right? Well, this is a method, right, to a server. So if we look at like just understanding the documentation here, godoc.org/net HTTP, and we look at listen and serve. So we have net HTTP listen and serve right here, and then we have server, right? And a server has its own method listen and serve. So how does that all work? Well, I got to respond to my friend Rio. Oh, cool. She's right here in class. Thank you, Rio. That's the image I'm looking for. I'm going to save that. Save image as HTTP diagram. That's a great name for it. And I think it should go to documents. So let's keep it there forever. Thank you. Right, we got two listen and serves there. And here, this listen and serve, look at what it's doing. Does that look familiar? So that's what I wanted to show you. Like, oh, holy crap. That's when we built up our TCP server from the ground up. We did that thing, right? Our HTTP server right from the ground up. We were doing this. And that's exactly kind of what, in the background, right, when we use, and I'm sure there's a little bit more to it, right? Obviously, a little bit more involved code. But when we use HTTP listen and serve, that's all being done for us. And so we just pass in the port and then a handler, right? The port and a handler, an address and a handler. And so what is a handler? Like if we go and look at the HTTP documentation, listen and serve documentation. So we're looking at this one right here, right? Top level listen and serve. Listen and serve takes an address and a handler. When we click on a handler, I think we did this last week, it's feeling familiar. It's something that implements this interface, right? That has that method. So anything that has that method can be passed in right here because it's a handler. And so we created our own servmux, HTTP new servmux. And a new servmux, if we go look at what a servmux is, servmux, here we have a servmux and new servmux. It gives us pointer to servmux, which means we then have all these methods available to us. And so servmux is an HTTP request multiplexer. So multiplexer means it could do routes, right? It matches the URL of each incoming request against a list of registered patterns and calls the handler for the pattern that most closely matches the URL. So here we get a servmux, and then we could say things like mux handle func, right? If we look at the methods that are attached to the mux, and don't get mux and multiplexer confused. Those are two different things. Or sorry, mux and mutex is confused. Mux and multiplexer are the same thing. Mux and mutex are two different things. But with the servmux, we've got handle and handle func. Right? So if we want a handle, we could give it a handler. So at this pattern, pass in a handler. And so that's what we're doing right here. Well, no, not right here. Those are handle funcs. But there's an example in see if I have that example here. So here, right, that would be creating my own handler. So any type, attach the serve HTTP method to that type, and then that type becomes a handler, and I could use it wherever a handler is asked for. So listen and serve is asking for a handler there, right there. So I could just say right there, and it would do whatever when right, there's no pass or anything. Everything is just 9,000, right? But it will do whatever I put in here. When somebody goes to that port, it'll serve this serve HTTP. So the point being is we have handle as a method, and we also have a handle func, right? So handle takes a handler, and handle func takes a function, right? A handler function with this signature. Okay. So if we have a function with that signature, then that is something we could use with handle func. It's a handler func. So handle takes a handler, handle func takes a handler func. A handler implements that handler interface, has to have that serve HTTP method with the response writer and the request, and a handle func, right? Like, so just look at the handler interface, right? Has to have this method, response writer and request, right? That looks really close, response writer and request. So that's a handler. So a handle, right, takes a handler. So if we'd use handle here, we need to pass in a handler. But if we use handle func, we pass in a handler func, which would be this. So serve HTTP that, and here's our own method with pretty much the same signatures. Just instead of serve HTTP, I called it uptown. Does that make sense? I mean, it's just kind of interesting. So now it'll do all that other stuff for us in the background, and you can see how I've added different routes here. SVC, and here we have servmux. And instead of creating our own servmux, right here we created our own servmux, and then we pass that in as the handler because new servmux, right? The mux must be a handler. It must have that serve HTTP method. We saw that last week. So we could use that right here because listen and serve asks for a handler. Or we could just pass in nil. And this is where we left off last week. And when you do nil, it automatically uses the default servmux, which is a variable. And default servmux calls, is a variable set to calling new servmux, right? So it gives you the same thing in effect. So you could just put nil here and use HTTP handle func up at the package level, right? And that does the same thing. So that's where we left off, and this is where I want to give Rio in the last 6 minutes. Sorry, I got 10 minutes. It's 4:50 according to my computer. I was like, what? So much time went by. Last 10 minutes. I want to blow your minds a little bit. And so, we are on 25, and we'll work through all this stuff. Well, I don't want to move that. We'll work through all this stuff to get up to what I'm going to show you. But what I want to show you is right here. And right here. Whoa. So this is App Engine Data Store. And just wondering if this is the one I want to show. I think I'll start out right here with put. All right, this is good. So let me change to that. And I run go app serve. And so that's going to fire up App Engine. So we learned TCP, Telnet, TCP servers, and then build an HTTP server on top of that. And then use HTTP listen and serve, which is all that already done for us, right? And we could do all that, and then we could create binary, and we could just deploy it somewhere. Or we could use App Engine, and we'll make certain changes, to our code, very minor, to use App Engine. Like we won't have listen and serve because App Engine is going to do that for us. And you won't have a main because App Engine uses main, so you have an init. And those are really the only changes. And then you just say, okay, go app serve, and it'll run locally, or you deploy it, and it goes up to the cloud, and it'll run on Google's infrastructure, and you could associate a domain with it. But now I've set this up, and anytime that you're running App Engine, you could go to localhost 8080, and it'll show you whatever your project is. And you could go to localhost 8000, and it shows you like an admin panel. So right now at the admin panel, I could go into Data Store Viewer, and I could look at the words, and I could list the entities, and you can see I've put up these different entities, right? And so in App Engine, it's a NoSQL database. I'm just hitting speed a little bit right here, and a NoSQL database is like this. Sorry, wrong semester. So here's a NoSQL database compared to a SQL database. In SQL, we call it a table. They have records, and the records are made up of fields. In NoSQL, we have kinds, and kinds have entities, and entities have properties. And so the way that would translate is just like, dang it, really? I got to change the words that I use. But the kind would be an employee. The entity would be an instance of that employee, a variable of employee type with certain values: name, role, hire, date, count. Those would be the properties, right? And so the way that works in an App Engine is like here, I could come to my thing and what's an animal? Somebody give me an animal.
Cat.
I already have cat in the database. Give me another one.
Squirrel.
Squirrel. Which I don't know how to spell. I think that's right.
Right.
An animal of great interest and distraction. 2 dogs. So I did that, and then I could come over to my data store viewer, and I could choose list entities, and whoa, now I have squirrel, and it gave it an ID over here, right? Whereas over there on the right, I have key name. So you could set it up where you say to your NoSQL to data store, right? Automatically generate an ID and keep track of the ID for me. Or you could set it up to you create the ID, right? And so if it's going to be a dictionary, I think I want the word to be the key by which I access it, right? So all of that, to do all of that, is right here. Not that much code. And I think the second version here is the one where I'm doing it with, my own key, new key. So here's how it works. So func init, handle func, just any route that comes in, right, is going to handle index. I have a struct, a term and a definition, 2 fields, right, that are keeping track of, the word and the definition. And then a handle index. If the request is post, I'm going to run all this code, right, from there to there. And so the term is equal to whatever came in on the form from the field named term, which is right here, right? And then the name is term, and the definition is from right here, so that's the form. And then I get a context. Context is just a bundle of values, just like if we are passing around a session ID or something, that's what Google's doing behind the scenes. So we don't have to worry about all that. We just say new context anytime we need it, and everything takes a context, so you need it pretty much in every function. And then I say to data store, create a new key, but it's going to be an incomplete key because I want you to come up with the ID. And I have to tell it the context, like who's asking for this, what is the application. I have to tell it the entity, I have to tell it the kind, so basically my table. What table do you want it put in? What kind do you want it to be? And then nil is for if it has a parent key for an ancestor. So for instance, if like I was creating some sort of a social application and this is going to be a post from a user, the post to that parent would be the user, right? If Bob was making a post, I would put in here, Bob's unique ID to let me know this came from Bob, right? And this is one of his posts. But there's no parent for this. So now I create an instance of a word, right? Or I create a variable of type word and give it a value. And I actually don't want to take the address right there. This is exactly the same thing. I just think it's better design practice to take the address. When you need to give something the address, give it the address. Otherwise, don't get the address. Just create the value, right? And so, and then I say data store put that up to the data store. And so I give it the context, I give it the key, and I pass in what I want it to put, and it takes all that and sticks it up there. So in the word kind or the word table, right, it's stuck, this entity I created right here, I call that anything, of this struct, and it just sticks it up there. And if I change the fields, it changes the data store. It's schemaless. The schema could change on the fly, right? And if there's an error, and then that's it. That's it, and then I just, print out the post. So I'm not showing, you'll notice I'm not showing any of the words here. Only submitting. I'm seeing the data coming in over here. And so to display the words, that's kind of like what the next step does. Like right here, instead of, so if I ran the second version, let's just see this run so you can kind of like leave with a little bit of a difference. And I'm going to change to the second version and then go app serve. And so now if I come here and run this one, Somebody give me a new animal.
Dolphin.
Dolphin. Kick, 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 kick. I submit that. I come over to my data store viewer and list my entities. I've now done the key right there. And so I could then go back and change that, right? A fish in the sea that is pretty when it jumps. This is the opinionated dictionary. A fish in the sea that is. It's like, holy cow, that's the Holy Grail, and not that complex, man. And that is like at Google scale, meaning so scalable, millions of users, way beyond what PHP, Node.js, Python could do, you know, in terms of like performance and scalability. And you know how to do create, read, update, delete. I mean, or you're like spitting distance away from it, you know. And this code, right, is not, oh, okay, create a context, pass the context. Oh, okay, it's not a table, it's a kind. Tell it which table kind to put this data into, right? And then you get it back out and start putting it into web pages. So what we've done with templating, learning templating and data, and what we've done learning the language, like all that foundation, now it's like, whoa, another big stride. Like we took a big stride last week, right? But this is not far away for us. You know, we are right now right here. So we'll basically look through the rest of these files, and then we'll come back up here, and that's about, you know, muxes, serving files, you know, and that's where data store is. You know, just look through this stuff here. How was that for an ending, Rio?
Awesome.
Isn't that cool?
What number is that up on GitHub? I was just trying to find it. Have you
53 data store. 0202. Oh, I don't know if I've pushed it.
Have you pushed that?
Rio. I have the most.
Yeah, I saw some of your commit messages.
Never gonna get a job anywhere. I'll have to create my own job.
So you're gonna. So it's number what? Because I want to look at it later if I get a chance.
5302 is kind of where we were. So I will send that to you
Cool.
when I'm offline.